Hello everyone, I am Balaji Rao. Welcome to BR Max class. This is 11th class in Continuity chapter. Till now, what we learn in this chapter? We learn what is continuous function. When we say function is continuous function at a point, and we learn how to check the function is continuous function or discontinuous function, and we learn how to check points of discontinuity. All these things we learn till now in this chapter. In this class, what we are going to learn? You observe this problem. Discuss the continuity. Discuss the continuity of cosine, cosecant, secant, cotangent function. You know cosine means cos function, cosecant means cosec function, secant function, cotangent means cot function. Discuss the continuity of these functions. Actually, discussing the continuity of trigonometric functions. I'll discuss continuity of sin x, I'll discuss continuity of cos x, I'll discuss continuity of tan x, I'll discuss continuity of all trigonometric functions in this class. And I'll discuss these things also. You observe this example. Find all points of discontinuity of greatest integer function. I'll discuss continuity of greatest integer function. When f of x is step x, what is its continuity, where it is discontinuous, and I'm going to discuss this one also. Fractional part function continuity, where it is continuous, where it is discontinuous, all those things we are going to learn in this class. Before going to start this video, please drop a like for this video. Without much delay, let's begin the class. Okay, discussing continuity of all trigonometric functions. To discuss continuity of a function, there are two methods. One is formula method. They'll give the function and I'll identify domain of the function by using the formula limit x approaches to a, f of x equal to f of a. I can check where the function is continuous, where the function is discontinuous, all those things I can check. Till now we did like that. That is one method. Another method is graph method. What is graph method? We'll draw the graph of the given function, because in class 11 we learn standard function graphs. We know all trigonometric functions graphs. You know how sin x graph will be, what is cos x graph, what is tan x graph, how it will be, what is its domain, what is its range. All those things we learn in class 11 chapter, class 11 mathematics. So when given function is a standard function like modulus function, greatest integer function, trigonometric functions, in that case, what I'll do, I'll draw the graph of that function and I'll discuss its continuity. What I am trying to say, there are two methods to discuss continuity. One is formula method. Till now, whatever the problems we did, they are all formula method. Now this is graph method. What is this graph method? When the given function is a standard function like sin x, cos x, tan x, modulus function, secant x, fractional part function, in that case, I'll draw the graph and I'll discuss its continuity. Okay, first thing, you observe here, I'm going to discuss continuity of the function sin x. We'll discuss continuity of the function sin x. Okay, you observe here, I taken f of x is sin x. I'm discussing continuity of sin x. What is the domain of sin x? In trigonometry chapter, you learned domain of sin x is all real number. The sin x function is defined for all real numbers. What is range of sin function? Range of sin function always lies in closed interval minus 1 comma 1. Whatever real x value you take, sin x always results a number in between minus 1 and plus 1. You observe this graph. You need to memorize this graph. You need to know this graph. You need to memorize this graph. Here, this is graph of sin x. This is graph of sin x. I drawn this graph from minus 2 pi to plus 2 pi. Actually, its domain is all real numbers. We cannot draw the graph for all real numbers. For entire real numbers, the graph flow will be like this. Okay. So this is graph of sin x. This is graph of sin x. how to discuss graph of this, how to discuss continuity of this function from graph. You observe its graph, you start from here, you observe its graph, you observe that is there any gap in its graph on its entire domain. And remember one thing, very important point, discussing continuity of the function is always meaningful when we discuss continuity in its domain. Discussing continuity of the given function is always meaningful when we discuss continuity on its domain. Okay, so on its domain, is there any gap in its graph? There is no gap in its graph, in its domain, correct? So what I can say? Can I say this function is continuous function? As I know the graph of sin x, directly I can say this function is continuous function. So I'll write here, there is no gap. There is no gap in the graph of f of x in its domain. In its domain. Okay, there is no gap. There is no gap in the graph of f of x in its domain. As there is no gap in its graph, then what I can say? I can say that f of x equal to sin x. This is the function, is continuous function. Continuity is always meaningful to discuss continuity of a function. We always discuss continuity of a function on its domain. Continuity is always meaningful to discuss on its domain. Okay, so I checked the continuity of the first function, that is sin x. I got that it is a continuous function. Okay, good. Now we will check the continuity of cos x. You observe here, what is the function? F of x is cos x. The function is cos x. You know, in class 11 you learned domain of cos x is all real numbers and range of cos x is closed interval -1, 1. You need to memorize these things. Domain ranges also plays important role. You need to memorize these things. Here, what is the function? F of x is cos x. What is the domain of this function? All real numbers. What is range of this function? Closed interval -1, 1. I am going to discuss continuity of this function with the help of graph. First, you draw the graph of cos function. You draw the graph of cos function. Now, you observe the graph. You observe the graph in its domain. You observe this graph. Is there any gap in its domain? Is there any gap in its graph? There is no gap in its graph. Correct? There is no gap. Is there any gap in its graph? There is no gap. So what I can say? I can say that this function is continuous. So cos x function is continuous function. What they are asking? Discuss the continuity of cosine function. Cosine function is continuous function on its domain, on its entire real number. See here, if we proceed further, we will get graph like this. If I proceed further, we will get graph like this. Okay, so what I can conclude here, I will write this. 1 minute. Okay. There is no gap. There is no gap in the graph of 1 minute. This function is what? This function is cos x. Okay. You observe here, there is no gap in the graph of f of x in its domain. Therefore, f of x equal to cos x is a continuous function. I hope you understand. We discussed the continuity of cosine function, right? So last last problem, what we discussed? We discussed the continuity of sine function. Sine function is continuous function. Now we discussed the continuity of cos function. Cos function is continuous function. Okay. Now you observe this one. Some interesting factors are there in this. You observe. I am discussing the continuity of tangent function. Tan x. F of x is tan x. What is domain of tan x? Here you observe, domain of tan x is all real numbers except odd multiples of pi by 2. Here I will tell you few things regarding tan x. Suppose tan x is there. Tan x can be written as sin x divided by cos x. Whatever point I am saying, that is about domain of tan x. You see here, we know that tan x can be written as sin x by cos x. Whenever cos x is 0, in that case tan x is not defined. When cos x is 0, when cos x is 0, when x equal to odd multiple of pi by 2, 2n plus 1 into pi by 2. Cos pi by 2 value is what? Cos pi by 2 value is 0. Cos 3 pi by 2 value is what? Cos 3 pi by 2 value is 0. Cos 5 pi by 2 value is what? Cos 5 pi by 2 value is 0. Whenever cos x is 0, in that case, tan x is not defined. So, what is the domain of this function? Domain of this function is all real numbers except odd multiple of pi by 2. When I take x equal to pi by 2, cos pi by 2 will become 0. That means denominator is 0. Then tan x is not defined. I hope you are understanding. So, what is the, you need to memorize these things. Which one you need to memorize? Domain of tan x. What is domain of tan x? All real numbers except odd multiple of pi by 2. And what is range of tan x? Range of tan x is all real numbers. Range of tan x is all real numbers. Okay. You observe, by seeing the graph, immediately you may confuse that this is discontinuous function. Immediately you may confuse that this is discontinuous, but actually this is not discontinuous, it is continuous. What I said, continuity is always meaningful to discuss in its domain. You do not discuss continuity of the function at odd multiple of pi by 2. Don't discuss the continuity of this function at pi by 2, because tan pi by 2 is what? At pi by 2 the function is not defined. At pi by 2 the function is not defined. So do not discuss continuity of the function where it is not defined. You always discuss continuity of the function in its domain. Okay, so you don't look here, there is a gap in its graph. Okay, what I'll do, I'll start checking. Now you observe, is there any gap in its graph or not? You observe here, graph is like this, there is no gap. But at 3 pi by 2 there is a gap is there. Here is the gap. But this minus 3 pi by 2 is not in its domain. Minus 3 pi by 2 is odd multiple of pi by 2. So do not worry, as minus 3 pi by 2 is not in its domain. Even though there is a gap at minus 3 pi by 2, no need to worry. See here, at this point, look here, at this point graph is there. As soon as it crosses 3 pi by 2, graph starts. Please observe here, it can be understood easily. Right? Now there is no gap. No gap, no gap. But at pi by 2, there is a gap. But pi by 2 is there in its domain? No. Pi by 2 is 1 into pi by 2 now. What is the domain of this function? All real numbers except odd multiples of pi by 2. Correct. So here, do not worry. Even though there is a gap at minus pi by 2, you need not to worry, because this minus pi by 2 is not in its domain. I hope you are understanding. Right? Okay. Now see here, the graph is continuous like this. As soon as it crosses pi by 2, again its graph starts. Its graph starts. Here gap is there at pi by 2. You need not to worry, because pi by 2 is not in its domain. Continuity is always meaningful to discuss in its domain. Even though here gap is there, nothing to worry, because at pi by 2 is not in its domain. Okay. So here what happened here, again it's continuous. And again it continues. Is 3 pi by 2 is there here, odd multiple of pi by 2. Odd multiple of pi by 2 is not in its domain. So what I am trying to say, main point, continuity is always meaningful to discuss in its domain. Okay, that is the one main point. Here in its domain there is no gap. There is no gap. This function is continuous function. You may easily misunderstand that tan x is discontinuous function. No, not only tan x, all trigonometric functions are continuous functions. All trigonometric functions are continuous functions. Continuity, you try to understand why I am repeating this point so many times. Continuity is always meaningful to discuss in its domain. Whatever the problems I am doing today, all the problems by using graph method. To discuss continuity of the tangent function by graph method, you need to know, you need to memorize the graph of tan x. Okay, so what I will conclude here. 1 minute. There is no gap in the graph of f of x. Here what is f of x? F of x is tan x. You observe here, there is no gap in the graph of f of x. There is no gap in the graph of f of x in its domain. That is important. Listen here, it is important. I am discussing continuity in its domain only. There is no gap in the graph of f of x in its domain. Therefore, tan x is continuous function. Continuity is always meaningful to discuss in its domain. Okay, now we'll move to next one. What is this? This is cot. I am discussing continuity of the cotangent function. Cot x. What is the domain of cot x? Domain of cot x is all real numbers except n pi. Here, what is a cot x? Cot x can be written as cos x by sin x. Cot x can be written as cos x divided by sin x. You observe this one. Whenever sin x is 0, in that case, cot x is not defined. So, when sin x is 0, when x equal to n pi, then sin x is 0. So, from I need to remove the x values for which sin x is 0. So, cot x is what? All real numbers except n pi, where n is an integer here. Okay, right. So, you need to memorize this. If you understand this reason or not, it's okay. But you need to memorize that domain of cot x is all real numbers except n pi. What is range of this function? Range of this function is all real numbers. Okay. Now, I'll discuss continuity of this function with the help of graph. To discuss continuity of cot x, you must memorize how to draw the graph of cot x. Okay. Now, you observe this is the graph in the interval minus 2 pi to 2 pi. And you know that this function is not defined at n pi. You look here, pi, at pi, 2 pi and minus pi, minus 2 pi. At that points, this function is not defined. Now, you try to understand its continuity. You observe this graph. It is continuing like this. You may easily misunderstood that here gap is there. That's why this is discontinuous. But here the point is, this minus pi is not in its domain. Continuity is always meaningful to discuss in its domain. Continuity is always meaningful to discuss in its domain. So here at 0, 0 is there? No, 0 is not there in its domain. 0 into pi, n is an integer, I said now. So 0 is not there. Even though here gap is there, you need not to worry because 0 is not in its domain. So continuity is always meaningful to discuss in its domain. You observe here pi is there here. Pi is there. Pi is not in its domain. Even though if there is a gap, you need not to worry. So what I am trying to say, this graph is continuous in its domain. All trigonometric functions are continuous functions. By seeing this, you may feel that here so much of gap is there, here so much of gap is there. How it will be continuous? Continuity is always meaningful to discuss in its domain. So, in its domain, there is no gap in its graph. Okay? So, what I will say, final conclusion. Look here. This graph is cot x graph, no? Cot x graph. Cot x. You observe here. There is no gap in the graph of f of x in its domain. Therefore, cot x is continuous function. Cot x is continuous function. Right. So, we discussed sin x. Sin x is continuous function. Yes, it is continuous in its domain. And we discussed this cos x function. It is continuous function. Yes. And see this tan x. It is continuous function. And see this one cot x. This is continuous function. And not only these things, all trigonometric functions are continuous functions. You observe this cosecant x. What is the domain of cosecant x? Domain of cosecant x is r minus n pi. You need to know these things. Cosecant x is what? Cosecant x can be written as 1 by sin x. 1 by sin x. Sin x is in the denominator. Whenever this sin x is 0, in that case cosecant x is not defined. When sin x is 0, just now we discussed it now. Whenever x equal to n pi, in that case sin x is 0. So what is the domain? I removed n pi. So what is the domain of cosecant x? Domain of cosecant x is all real numbers except n pi. And range is all real numbers except open interval minus 1 comma 1. If you know this, very good. Otherwise, need not to worry. Now, what the thing is, our domain is r minus n pi. That means this cosecant x function, not defined at pi, at 2 pi, at minus pi, at minus 2 pi. Okay, even though there is a gap you need not to worry, because this minus 2 pi is not in its domain. All real numbers except n pi. N pi means, n is an integer. N pi means like 2 pi, 3 pi, minus 4 pi, minus 3 pi, like that. Okay. You look here, even though there is a gap in its graph, minus pi is not in its domain. Here also, pi is not in its domain. So what I am trying to say, these functions are all trigonometric functions are continuous in its domain. You may feel that there is a gap in its graph, but this point is not in its domain. So you need not to worry. 0 is also not in its domain. Therefore, this function is continuous function. So what to specify here? You observe what I written. There is no gap in the graph of f of x in its domain. There is no gap, right? Therefore, cosecant x is continuous function. I hope you understand this, right? So till now whatever we discussed, they are all continuous functions. I think next one more is there, that is secant x. Secant x, what, write its domain. What is its domain? All real numbers except odd multiples of pi by 2, because we know that secant x is what? Secant x is secant x can be written as 1 by cos x. Whenever cos x is 0, in that case secant x is not defined. When cos x is 0, when cos x is 0, when x is odd multiple of pi by 2, when x is odd multiple of pi by 2, in that case, when x is odd multiple of pi by 2, in that case secant x is not defined. So I removed that. You observe here, domain is all real numbers except odd multiples of pi by 2. So domain of secant x is all real numbers except odd multiples of pi by 2. What is the range of this function? Range of this function is all real numbers except open interval minus 1 comma 1. If you understand these things, very good. Otherwise you need to memorize. Okay. To discuss continuity of the secant x function, first thing you need to know how to draw the graph of secant x, or else you memorize the graph of secant x and secant x, and the secant x is not defined whenever x is odd multiple of pi by 2. Secant pi by 2 not defined. You observe pi by 2, 3 pi by 2, minus pi by 2, minus 3 pi by 2. At these points, this function is not defined. Even though here gap is there, continuity is always meaningful to discuss in its domain. In its domain, in the graph of the function, any gap is there or not, we need to check. Look here, this graph is going like this, going like this, going like this. You may feel that here gap is there, but gap is not there. This point is not in the graph. This point is not in the domain of the function. So as soon as it crosses this point, you look here, the graph starts here. There is no gap. Here you may feel that there is a gap, but the point is, this point is not in its domain. As soon as it crosses here, again graph starts here. So what the point I am trying to say, this is continuous function. All trigonometric functions are continuous function. You better remember like that. You may feel that here gap is there, that's why this is discontinuous. No, this point is not in the domain of this function. Continuity is always meaningful to discuss in its domain. So this function is continuous function. So what is the main thing I want to say? Right. Look here. What is this function? This function is secant x, na? Okay. Secant x, f of x equal to secant x. So there is no gap in the graph of f of x in its domain. This is important. In its domain, there is no gap in its graph. There is no gap in the graph of f of x in its domain. Therefore, the function is continuous function. Secant x is continuous function. So whatever the 6 trigonometric functions continuity we discussed, what we identified, all 6 trigonometric functions are continuous functions. Okay. Now you observe this. Find all points of discontinuity of greatest integer function. Greatest integer function is also known as step function. Why they call it as step function? If you observe this graph, these are looks like floor steps. This looks like steps. Failures are the stepping stones of success. All will say na, like that. These are like steps. You can easily memorize this graph. This is the standard graph. You need to know. So to discuss the graph of greatest integer function, you need to know the graph of step x, greatest integer function graph. Okay, first we will draw the graph of greatest integer function. What is the domain of greatest integer function? This function is defined for all real numbers. This is the domain. This function is defined for all real numbers. What about range? Range is an integer, because we know that what is step 1.38? What is step 1.38? Step 1.3 is 1 only. Step minus 3.4 is what? That is minus 4. All those things we learn in greatest integer function. I don't want to discuss here. Okay. So find all points of discontinuity of greatest integer function. To discuss continuity of greatest integer function, first I'll draw the graph of greatest integer function. Now I'll write its domain and range. Domain is all real numbers, range is set of all integers. Now you observe the graph. Is there any gap in its graph? This is the graph. Here the open circle is there. Now at open circle this is not defined. Look here. There is a gap. That means graph starts from here. Closed circle is there, means this point is there. Graph is moving like this. Open circle came na, immediately it jumps to here. There is a gap. There is a gap. You look here, it moves like this. Here open circle is there na, immediately it moves here. There is a gap here. So what I am trying to say, by observing this graph we can easily see that there are many gaps. Okay, but the point is, what is the domain of this function? Anything removed in the domain? No. Like earlier problems, domain is like r minus 2n plus 1 into pi by 2, r minus n pi, something like that. But here what is the domain? Domain is all real numbers. Domain is all real numbers. So here there are so many gaps. Where these gaps are, you identify. This gap is there at integer. 1 minute. Right, you observe at this point. What happened? Look here, at this point gap is there. Here gap is there. Gap is there. Gap is there. Gap is there. So what I am trying to say, greatest integer function is discontinuous at every integer. Look here, gap is there. Look here, at 2 gap is there. At 3, look here, gap is there. Greatest integer function is discontinuous at every integer. I'll write here. From the graph, f of x equal to step x, that means greatest integer function, f of x equal to step x is discontinuous at every integer. Here one more point. What you say about continuity of this function at 1.5? At 1.5, 1.5 is there in its domain? Yes. At 1.5, is this greatest integer function is continuous or discontinuous? Look here, we'll zoom this. 1.5 somewhere around here. 1.5 is there here. You look here, it is continuous at 1.5. I hope you are understanding. At 1.5, this is continuous. Suppose 0.5. You look here, in this zone there is no gap. But whenever integer comes, look here, this is 2 na. Whenever 2 is there, there is a gap. Whenever 2 is there, there is a gap. I hope you are understanding. This graph is discontinuous at every integer. At other numbers, suppose at 2.5, this is continuous or discontinuous, means it is continuous. At 3.5, it is continuous or discontinuous, means it is continuous. At 4, it is continuous or discontinuous. 4 is an integer. At every integer, this is discontinuous. I hope you are understanding. You understand this or not? If you understand, please drop a like. That's good. So what we came to know? We came to know that this greatest integer function is discontinuous at every integer. If someone asks what is the continuity of the function at x equal to 4.5, 4.6, then we say that it is continuous at 4.5, but it is discontinuous at every integer. Okay, now you observe this one. Question number 19, last question. Show that the function defined by g of x equal to x minus step x. This is fractional part function. This we learn in class 11, fractional part function. Okay, is discontinuous at all integral points. Okay, we need to show that. Yes, AB. Yeah, good. We need to show that this function, fractional part function, is discontinuous at all integer points. To check In how many ways we can check the continuity? Two ways are there. One is formula method, another one is graph method. This is fractional part function. This is standard function. You must know how to draw the graph of fractional part function. Okay. First thing, you learn how to draw the graph of, how to draw the graph of fractional part function. What is the domain of this fractional part function? Domain of this fractional part function is all real numbers. You can observe that this function is defined at all real numbers. And what is the range of this fractional part function? This is closed 0, open 1. 0 is included, 1 is not included. So you observe its graph. You observe the graph. This is the graph of fractional part function. I'll write here f of x equal to x minus step x. This is the graph of fractional part function. Okay. Now what you will say? Where it is continuous, where it is discontinuous. What is domain of this function? Domain of this function is all real numbers. Is it is continuous function? By seeing the graph, immediately you can say it is continuous or discontinuous. Is there any gap? You look here, the graph starts here, the graph starts here, here gap is there at integer, right? Gap is there. Now look here, the graph starts here, again gap is there at the integer. Okay, now look here, the graph is going like this, again gap is there at the integer. Graph is going like this, again gap is there at the integer. So what you identified? This x minus step x is discontinuous at every integer. Look here, at this point gap is there, at this point gap is there. By seeing the graph, easily we can say this is discontinuous at every integer. Correct or not? Yes. So what I'll say here, from the graph, I'll write here, from the graph, what you can say, from the graph, g of x, what is g of x? G of x is x minus step x, is discontinuous at every integer. Discontinuous at every integer. So from the graph, they are asking to show that this function is discontinuous at all integer points. To say this, I said that I drawn the graph. From the graph we can say that there is a gap at every integer. That's why this is discontinuous. Now if someone asks what is continuity of this function at 0.5, you discuss the continuity of the function at 0.5. You look here, this is 0.5 now. This is 0.5. You look here, there is no gap. There is no gap in its graph. I hope you are understanding, right? At 0.5, this fractional part function is continuous. You look here, what is this? 1.1 or 1.2, something you like. You take 1.2. At this point, it is continuous. This function is discontinuous at every integer. Okay. So we prove, that's why from the graph we shown that this is discontinuous at every integer point. I hope you understand this class. So we are almost about to complete this chapter. Hardly 1 or 2 classes are needed to complete this continuity. And if you like this video, please drop a like for this video and share this video with your friends. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Take care. Bye-bye.